So over the course of this next little sequence of videos, what we would like to be able to do is compute the cross product between two three-dimensional vectors. In our last set of videos, we did a lot of work with the dot product. So the dot product is sometimes referred to as the scalar product between vectors because the answer to that calculation is a number. The answer to a cross product calculation is a new vector. It is a more complicated calculation. It's sometimes referred to as the vector product because the answer is a vector. To set this idea up, we have to be pretty comfortable with computing determinants of matrices. So in an Algebra 2 course, pre-calculus course, you maybe have done a little bit of work with determinants. If you've ever used Cramer's rule to solve a system of equations, that would probably be the main place where you would have used it in the past. If you've done work with inverse matrices, different things involving matrices in the past, you've maybe seen some of it there too. But a 2x2 determinant is how we're going to start this discussion. And to find a 2x2 determinant, by definition, all we do is we take the main diagonal of the 2x2 matrix and we take a product, right? So you see A1 times B2. What we then do is we subtract off the product of the minor diagonal, right? So we've got the major diagonal from upper left to lower right, and then the minor diagonal from upper right to lower left. So major diagonals product minus minor diagonals product, and you have the numerical value for that 2x2 determinant calculation. Now what we really need to have access to in order to be able to compute a cross product, we need to have access to a 3x3 determinant computation. So the way that a 3x3 determinant is defined is within this definition box at the top of the screen here. So you'll notice that A1, A2, and A3 are the values from the top row of that matrix. And if you look at where A1, A2, and A3 popped up within the formula on the right side of this equation, they are the coefficients of 2x2 determinants. I guess I should have said this. Whenever you have brackets on the outsides of these, like I'm drawing in now, that represents a matrix. We don't have brackets here. What we have is we have what basically are they look like big elongated absolute value symbols. Whenever you lack the closure of those brackets, like I just added in and then removed, that indicates that you're computing a determinant rather than just considering it as a matrix in general. So when we compute this 3x3 determinant, the values in the first row come out as the coefficients of three smaller 2x2 determinants. You will notice a little bit of a weird thing happening with the signs. We have subtraction between the first, so when I say term, I'm referring to this as a term. We have subtraction between the first term and the second term, and then we're adding on the third term. So it's definitely pretty specific. The order can't be manipulated at all because subtraction is not commutative. So you definitely have to be really, really comfortable with this definition in order to be able to compute 3x3 determinants, and eventually in order to be able to determine a cross product between two three-dimensional matrices. The thing that you'll notice about the 2x2 determinants within each of these calculations, if you take this coefficient, this A1, if you cross out that row for A1 and the column that A1 sits in, you'll notice that the 2x2 determinant that sits here is what we have left down in this lower right-hand corner of this bigger 3x3 determinant calculation. The coefficient A2, if we do the same thing with it, cross out the row that A2 sits in, cross out the column that A2 sits in, you'll notice that this 2x2 determinant involves the components that are left after crossing out the pieces that we just did. And then the same thing happens for A3. So if I cross out the row that A3 sits in, I cross out the column that A3 sits in, by definition, the 3x3 determinant is going to finish by computing the 2x2 determinant with the pieces that remain right here, B1, C1, B2, C2. So we'll go ahead and we'll put this definition to use one time real fast. I didn't really write this out in detail. You might find that is helpful to you, I just went ahead and just threw out this calculation. So this is not a cross product. All we are asked to do here is compute the given determinant. And so what I'm doing is I'm listing these values, 2, 3, and -1 as my coefficients. So there you see the 2, the 3, and the -1. I have the order of the subtraction and addition the same way we saw it within the definition. I have subtraction between the first term and the second term, and then I have addition between the second term and the third term. So what am I going to do to this 2? What am I going to multiply that by? Well, I'm going to multiply that by a 2 by 2 determinant, and if I cross out the row, that's not a row, that's a column, excuse me. If I cross out the column that the 2 sits in, and I also cross out the row that the 2 sits in, what I have is I have this 2 by 2 determinant left to compute. So I'm going to multiply the major diagonal, get 3. I'm going to subtract off what I get when I multiply the minor diagonal, which is 0. That is just going to end up giving me a result of 3. For the value that's going to multiply the 3, I'm going to think about crossing out the row that the 3 sits in. I'm going to cross out the column that the 3 sits in. And what I would have is I would have 0 and 3 remaining as my major diagonal. Well, when I multiply those together, I get 0. And then I'm going to subtract off what I get when I multiply the minor diagonal. Keep in mind this middle row is crossed out. Maybe I can actually physically do that and then get rid of it in a moment when we need it again. So multiply the major diagonal. So these are both crossed out. Multiply the major diagonal, we get 0. Subtract off what we get when we multiply the minor diagonal, which is also 0. So that 3 is going to get multiplied by that 2 by 2 that we just talked out, which is 0. I'm then going to take that coefficient of -1. I'm going to cross out that row. So cross out that row again. I'm going to cross out that column. I'm left with this 2 by 2 determinant remaining. So I'm going to multiply the major diagonal to compute that 2 by 2 determinant, get myself a 0. I'm going to subtract off what I get when I multiply the minor diagonal. So I guess I'm subtracting off -2. Subtracting off -2 is obviously like adding 2. I then can just go ahead and do the multiplication that we need to and follow the order of operations to get my result. So I'm looking at 6 minus 0, I guess plus -2 or -2. So the value of this 3 by 3 determinant is 4. In the next few videos, we're going to take some time to define the cross product, talk about some terminology, or excuse me, some geometry associated with the cross product, and then do a handful of examples with it.